So pass forward, please. And thank you. Yours. What about your other one? Oh. So, the past couple days, when we have introduced what work is, what is work? The whole point of the chapter. You say that a little louder and slower.
The energy transferred to a system by an external force when it acts on the system too.
Okay, and then we said there are three things for work to be done. Raise your hand if you can tell me one of the things that need to happen for work to be done. Somebody different. Steven?
External force.
Okay, gotta have a force. Yep. Sydney?
The object has to move.
The object has to move. Carly?
The object has to move in the same direction.
The object has to move in the same direction as the force. So, if you have a force that's perpendicular to the movement, is work done? No. Alright? Then we talked yesterday that the purpose of a simple machine is to what? Everybody should say this. I said it like 25 times yesterday. Make the work faster, make the work easier. What doesn't it do? Change the amount of work. So the question today then, and we talked a little bit about this yesterday and also already a little bit today. How does a machine make the work easier? Okay? It makes the work easier by reducing the force needed to do the work. The question is, how does it reduce the force? Well, let's recall and look at this equation. If this is a constant and never changes, if the force goes down, what has to be true about the distance? It must go up. So, a simple machine can reduce the force by doing that force over a longer distance. What's the difference between having a little truck bed here? Bad drawing, but anyways. Okay, lifting a box straight up or going on a ramp? Which is more distance? Going up the ramp. It's easier to push a box or move a box up the ramp. Okay? Now, this is the distance principle right here. This might be the most important thing of the chapter. We will break down many different types of simple machines and how the distance goes up, making the force go down. Yeah, I'll explain that in a little bit. Question. On a different slide, I'll tell you what IMA is. IMA and AMA. Yep. What is it? So, and I'll define that on a different slide, but IMA is the ideal mechanical advantage, and AMA is the actual mechanical advantage, and I'll tell you why there's an ideal and an actual. Okay, but I'll get to that when it comes up on a different slide. Okay, I want to focus on this. Okay, the purpose of a simple machine is to what? Everybody say that again. What doesn't a simple machine do? Change the amount of work. How does a simple machine make work faster and easier? By doing the work over a longer distance, it makes it easier by reducing the force. That is the distance principle. All of our simple machines, if they give us an advantage, the reason why they give us an advantage is because you do less force over a longer distance. And here is IMA. This would be the distance you travel versus the distance your object travels. So, if you have an advantage, which needs to be larger? Just think mathematically here. To get an advantage, does the top number or the bottom number need to be larger? Top number. Now this should make sense. The effort is what you do, right? How much distance you travel. And we said to make work easier, we have to travel a longer distance. Do you guys remember the pulley system that you guys talked about last year? Okay? You remember how you just pulled and pulled and pulled and pulled and pulled and you barely moved at all? Why do you think that was? Because the distance you pulled was a lot so that the force got reduced, but the distance that the object moved was very little. Does that make sense? It's the distance principle in action. You were pulling away, but was it really hard to pull? No, it would have been a lot harder just lifting a whole person's body up, right? I don't know if you actually had someone sit on the pulley. Did you guys do that last year? Okay. Could you imagine trying to just lift that person up without it? It would take a lot more work, or not the same amount of work, but a lot more force. Okay. That was the distance principle in action. Oh, we had this. Didn't we have this one in yesterday? Okay.
Well, we had mechanical advantage, but it wasn't
It was a more wordy definition.
Yeah.
Okay. Basically, the mechanical advantage is how much of an advantage you get. Well, does more force or less force give you an advantage? Why would giving more force be advantageous for you? That makes sense? Okay? So when you have a mechanical advantage of 2, that means that the force that you exert is what? 2 times as easy or 2 times less? Okay, let me say it again. If you have a mechanical advantage of 4, that means the force that you apply is 4 times easier or 4 times less. Okay, it wouldn't make sense that more force would be easier, right? Less force is easier. Yeah? Okay. Alright, then this just defines those two different things that Stephen asked about and Mari kind of talked about, and then I'll kind of explain why there is even a difference between the ideal and the actual. Bit of work here for you. If you use a simple machine, it might be a little easier.
That one was a little bit too
Alright. So if you look at just actual mechanical advantage and ideal mechanical advantage, what is really kind of the main difference in their definition? Hey, didn't I have an equation for IMA?
Yeah.
What was the IMA equation? This? Let me see. I think the other equation's coming on the next slide. Yeah, okay. I'll just write it up here so I can kind of show you. AMA see this on the next slide, but I want to kind of put it up here to compare. The AMA equation has what in it? Force. The IMA equation has distance. Okay? Now, in theory, we know work is a force times a distance, correct? So both force and distance apply here. But if work stays the same, if I change one, the other one changes proportionally. So technically I could use either to find the advantage. Here's the difference. Okay? I could measure the distance from the ground to the bed of the truck, and I can measure the distance from the ground to the bed of the truck using an incline, and I can plug those in to figure out the ideal mechanical advantage. Okay? Let's say I plugged it in, and the ideal mechanical advantage was 2. Made up number. Okay? But then I calculated the force it required for me to lift it straight up, or the force it required for me to push the object up a ramp. Okay? They're not going to give you the same numbers. Does anybody have any idea why? What? Okay, absolutely. He just said no machine is 100% efficient. So is it possible that while I'm pushing the box up the incline, that some of my force has to not just overcome the weight of the object, but maybe to overcome a few other things? What do you think I'd have to overcome when pushing the box up an incline? The friction. Okay? So you're going to have to apply more force due to friction than maybe if it was a frictionless surface. So when I say ideal, this would be if I was in a frictionless world without air. Does that make sense? So that all my force went perfectly into it, and I didn't have to worry about some of the energy being dissipated into some other energy form. Okay? Is it ever going to be ideal? Are we ever in an ideal situation? Do we ever see a frictionless object with no air resistance? Okay? That doesn't happen. So typically, we will use AMA because I can measure the force I would need to lift the box and the force I had to apply to push the box up the incline. That is the actual because it's what I actually did. Does that make sense? So very rarely, in fact never, will you ever see the AMA and the IMA identical in a real world setting. Okay? That's why it says the actual mechanical advantage is always less, because normally your force you will lose some of your energy to friction or air resistance. Because no simple machine is what? 100% efficient. So, here's your equation. If you already got it in, fine. If you didn't, go ahead and put this in. I have it written a little bit different up there, so just know that the R, when it says FR, what is it referring to? No, the F is, what is the R referring to? Resistance. And what do you think the E is referring to? Effort. Which one do you do? Effort. The effort. And mechanical advantage does not have units because your newtons are going to what? Cancel out. So I plug in some numbers and I find the AMA is 2.5. Someone tell me what that means. Raise your hand. Tell me what it means if I have an AMA of 2.5. Sid?
It's 2.5 times easier.
Okay. Does that mean 2.5 times more force or less force? Less force. Think about what's easier. Less force is always easier. Okay? Let's do a problem. Everybody got this? Okay, do this. They want AME, right? I'll just say FR over FE. Now they said in the equation just below, they said FR is the weight. All right, if I have a box and I want to lift it, don't I have to apply a force equal to the weight to lift it? Like if you couldn't apply a force strong enough to overcome the weight, is it going to move up? No. So, when we are trying to figure out the AMA, the resistance force is always the weight of the object you're moving. Because in order to get it to move, you've got to apply a force equal to the weight. So if I have a 3,300 Newton piano, I have to apply 3,300 newtons to lift it without a simple machine. If I use a simple machine, the simple machine could potentially what? Reduce the force by doing it over a longer distance. Right? So if we look here, we use the pulley system. Okay? Using a pulley system, we had to pull a rope through the pulley system a pretty far distance, but what did it do to the force? Reduced it. So again, you start thinking, well, which number is which? Well, think about it. What's the purpose of a simple machine? To make it easier. Okay, that means you want an advantage. Well, what number would have to go on top to give you an advantage? The bigger number. Okay, also, I think you can understand that that's the weight of the piano. And then it says the effort force is. So that helps. Okay? So we've got 3,300 newtons divided by the amount you put in. What is your mechanical advantage? 6. So what does 6 mean? 6 times easier. Or 6 times less work. Not work. Force. Big mistake there, didn't I? What was the mistake I made? The work doesn't ever change. All right, perfect. 6 is your AMA. Questions? We're done.
I love you, Kramer.
What?
Let's only give you one.
One number.
Oh, Kramer.
Did they do that in problems?
30.
Kramer, I love
We only give you 33,000.
Guys, don't do 30.
Thank you.
That should be in the pulley section, not in that section.
Good job, Ethan. I love you. Huh?
You're welcome.
And we only have one call.
Yeah, don't do 30. That should be in the pulley section.
Kramer, if I
I
could
was
just
looking at that
have
and I was wondering.
What?
if I could just have.
No, they didn't. I don't believe
Can we
it.
play silent ball?
I got
It's 5 and 31.
You could literally copy down the problem later.
You know why that's so difficult?
So we're not doing 30?
I'm just scared.
I'm scared.
I'm just scared.
Oh.
Play silent
Come
ball.
on, let's play. See if you're actually scared.
That's why I take you out in Fortnite.
Huh?
What?